Okay, this is a. So in this presentation, I will briefly explain to you about the first assignment, which is here. This is for pattern recognition. Okay, let it come. Yeah, this is the first assignment. So here, this is individual assignment. You should not use not use a machine learning library. For example, if you are using Python, you cannot use scikit-learn. You have to code everything from scratch. Remember to submit a report because that is your submission. There is a report in the format PRA1 underscore roll number. It has to be exactly in this format because it is going to be auto processed. So please make sure that this is the roll number and it is in lowercase. The report should include a Google Colab page with your code and output because we want to be able to run what you have done. It is due on 10th October. So in the first question, you are going to perform what is known as speech activity detection, and you're going to compare the performance of two SAD systems. First, let me explain what you're doing. This is segment 2. Okay, so this is an example of a speech segment. I can play it out, but I don't know if you can hear it. Will the recording capture it? I'm not sure. Let me run it.
Not even a year yet, but they're already engaged. Yeah, I guess I don't know.
Okay, so this is just a speech segment, and so you can see that in many times, so there is some speech activity going here. So I'll share the audio file so you can hear it. So there is some speech activity going on here. Then there is some silence, some pause when the speaker is talking. There's again some speech, again some pause, and there's again some speech. Okay, so there are a lot of pauses in between the speech. And this is recorded in a noisy environment like a restaurant or something. So there is sort of background noise. So your task is to detect the presence of speech. So it's a binary classification problem. Either you, so every segment in this audio signal is either going to be classified as either speech or non-speech. Speech means there is actually somebody talking. Non-speech means there is no talking, there is only some background noise. So your classifier must be able to discriminate between speech and non-speech. So that is the main aim of the task. So for this, you will use two types of features. They are one-dimensional features, and the features are energy-based features. This is the signal energy. So it's just short-term energy, and the other energy is MEL filter bank energy. Okay, so there are two different types of features. 1D features. I think I should be. So okay, this is question 1. So for example, these are the files which I will share with you. I will also share the audio. So for example, now let's say there are this is segment 2 short term energy. So it is just a simple CSV file. So you can see there are some energy values, right? There is some real numbers. These are basically the signal energy values. And also provided is the ground truth, which is basically is ones and zeros. 1 means there is speech, 0 means it's non-speech. So what we do additionally, I mean, typically in speech processing systems, what we have done, I will try to draw it here. So suppose this is my speech signal. I have some audio signal here. Okay, so what we typically do is we divide the audio. So these are all sampled digital signals. So we divide them by using small windows into what are called frames. Okay, and then I compute the energy for this particular frame. I have the samples here as put it as a array, and I compute its energy and I get a single scalar value. So for the second one also, the samples inside here are squared and summed, and that forms the energy. This is the frame 1, this is frame 2, frame 3, frame 4, frame 5, frame 6, frame 7. So this segment is divided into 7 frames, and for each frame I get one value of energy. Okay, so basically my feature representation for this particular audio signal will have 1, 2, 3, 4, 5, 6, 7. 7 real numbers. They're all real numbers, all belong to R. One dimensional. Okay, so there are two types of energy. One energy which I have used is the short time energy. The second type of energy I have used is Mel energy. Don't have to worry about what they are. You can just think of them as two different types of features which you have extracted from this audio signal. So now the question is, we are going to build a SAD system, speech activity detection system, using both these features. Which one is better? Is ST better or is Mel energy better to detect speech? That is what we are trying to address. So now if I try and plot, yes, run this here. So this is how my audio signal looks like. I've just plotted that. These are how the energy values look like. Okay, there are two types of energy here. So there is short time energy, which is in blue, and there is a Mel energy, which is in orange. So you can, so this is per frame. So that this particular audio signal having so many samples is divided into 250 frames. Basically, you just think that you have 250 features to classify. So you must make the decision 250 odd times. So for every frame, you have to make the decision whether it is speech or non-speech. So these are the energy values based on these values. So there is some offset here. This one is a little higher, but that you don't have to worry. You have to use the blue features and build the SAD system. You have to use the orange features and build the SAD system. Right. So basically, you will have to decide what is the threshold you're going to use to decide when it is speech and when it is non-speech. So that is the, if you do it over all thresholds, that is when you get your ROC curve. Let me again come back to here. So I've also shown you the ground truth. So there are two segments here, segment 2 and segment 3. So you should do the model building. So you can use segment 2 for training and you can use segment 3 for testing. In both cases, the ground truth is given. The actual decisions are given by which you can evaluate the performance of your system. Now, coming back to what you must actually do. So you have this. So what you do is, new page after. Okay. New page at end is what I should use. Okay. Yeah. So here, what you should do is, you have two types of energy values, short time energy and Mel energy. So the idea is that we are going to estimate a Gaussian distribution for both of them. You can use a simple univariate Gaussian. And essentially, the idea is that the energy for speech will in general be higher than the energy for non-speech. So you can, there's some distribution for, so if this is the energy value, some distribution is there for non-speech, some distribution is there for speech. Let me say this is speech energy, and this is non-speech energy. Now your question, your idea is to now to detect the speech. So basically, if this is again the audio signal, some speech segments are there here. You are now going to, your classifier should ideally give you distance, binary distance like this. So this is speech. This is also speech. This is also speech. Okay, so this 1 means it is speech, 0 means it is not speech. So it's a binary classifier. 1 stands for speech, and this is for non-speech. Okay, so now basically what you can do is now you have to use your training data, which is your segment 2, is your train data, and you estimate the distribution for speech. So you look at all the, so see the ground truth for segment 2, all the ones, pick up all the energy values corresponding to these ones. All of them should have the same size. Okay, so in segment 2 has 256 samples, 256 frames. So you pick up the frames corresponding to speech, that is all corresponding to the ones here. And with that, you estimate, you can just find out a simple maximum likelihood estimate of this Gaussian distribution. Just take the sample mean. So that will give you the mu speech. And that will also give you the variance speech. Okay, we are going to assume it is Gaussian. It's normally distributed with Gaussian. This is the energy. This is the energy values. Okay, are distributed according to this. This is actually the speech energy. So now you are now going to, on the test data, which is segment 3, you are now going to, for every, so there are, the segment 3 has got how many? I think 275 frames. I.e. 275 energy values, which you must classify as speech or non-speech. So for that, what you will do is you will, for every xi is the speech value, is the energy value, you compute, you estimate probability of xi given speech. Okay, and you will get some value p. Xi is the ith observation. Like that, you have 275 of them. You will get some p. You will see whether this p is greater than some threshold p star. Okay, you fix one initial threshold, and you do this for all the i's. I goes from 1 to n. N here is 275 for energy values for segment 3, which is your test data. Find out how many of these probabilities are greater than this threshold p star. And with that, you compute the true positive rate and false alarm rate. This is also called false positive rate. TPR and FPR. Okay. You can get the formulas for these. Wikipedia or something you can check, and you get what is true positive rate, and then you get what is false alarm rate. Now, you start plotting the ROC curve. This will be the TPR. This will be the FPR. So for this particular threshold, you will get a point here, a single point, which is the TPR and FPR. Like this, you do for various thresholds. P1 star, P2 star, and so on, so on. Each of them, for each of them, you will get 1 point, and you will get some curve. You will probably get some curve like this. Okay. So this, each of these points consist of different thresholds. Actually, you might get the curve like this also. I'm not able to say now how the curve will look like, but you should get something like this. Now I'm drawing multiple curves here because if you have to test multiple systems, you have to do multiple curves. You have to repeat this. So first time you will do it with STE values. Your XI are the STE. This is your system 1. System 2 is your MEL energy XI values. So then you will repeat this for system 1 and system 2. And then you will plot the ROC curves for system 1 and system 2. And maybe this could be for STE and this could be for MEL. This is not there. I mean, this curve I just drew it initially, but you will probably get two curves like this. And the higher up the curve is, better is the system in detecting speech correctly. Okay, so you can refer to you can refer more about it in DudaHeart in section 2.8.3, or you can also look up ROC curves generally online. So you will each ROC curve consists of true positive rate and false positive rate for various thresholds. So this will be for the first system, maybe using short-term energy, and this will be the curve for MEL energy, system 2. Again, for this also you'll have to use various thresholds, and for each threshold you have to estimate the true positive rate and a false positive rate, and that will give you 1 point in the curve. Like this, you have to keep repeating for both the systems because we are comparing two systems here. And then you summarize based on what are the plots you get. I'm not sure how the plots will look like, but I think you should get something like this. Based on this, you decide which system, which feature, the system using short-term energy, or is it the system using MEL energy, which is better at detecting speech. To estimate these things, the ground truth file can be used. Okay, so that is the first question. You need to write the expected output is the ROC curve for the two features. Second question is pretty straightforward. It is a direct application to the various cases which we covered in linear discriminant analysis. So we are developing a base classifier, and we are assuming a univariate, no, it's not univariate. It is unimodal Gaussian, but we are using two-dimensional features. And there are three classes, and you have to classify them. You have to build different classifiers which are more and more complex. For example, first classifier is the first case which we said has the same spherical covariance for all classes. Second one will have full, that is non-spherical, but equal covariance for all classes. Third one will have only diagonal covariance distinct for each class. And fourth one is full covariance distinct for each class. So the four types of classifiers you will build. And I have also, in each case, you can use the sample mean to sample mean and sample variance. You can just use the maximum likelihood estimates. And then you are going to summarize the classifier based on these metrics: accuracy, precision, recall, and F-score. This is class-wise. Okay, so accuracy means how many out of the number of examples, number of test examples, how many are classified correctly, and the percentage of that. So I have asked you to use 50% data for training and 50% data for test. The data actually look like this. For example, the class 3 data, it is just two-dimensional data like this. And I think there are 500 data points in each case. 100 data points are there. So 250 you will use for training and 250 you will use for testing. There are two data sets. One is a linearly separable data set. The second one is non-linear. I will show you the data. Like this. So the linearly separable data look like this, and the non-linearly separable data look like this. In each case, you're going to use a Bayes classifier of varying complexities to classify these three classes. So 2 data sets are there. So you have to build 4 classifiers, C1, C2, C3, C4, and you have to plot the decision regions with the class data in different colors. So since there are 2 data sets and 4 classifiers, you will have 8 plots, and this is a sample plot. So this is some other data, but similar data. This is linearly separable data, 3 classes, 3 different colors, and these are the decision regions. So to find these decision regions, one way to do it is either you can find out these decision boundaries, or an easier approach could be to find out the discriminant at each of these points in this grid, and then classify it based on which decision region it belongs to, and put some color for that. You'll have to do it for all the points here. You can use some, you can increment each dimension x and y by a small amount and evaluate. So that is another way to do it. But like this, you will get 8 plots. This is for the linear case. The non-linear case also, the data you've seen, it will look like this. So you'll have some decision boundary, some complicated non-linear decision boundary you will have here. Okay, so that is the assignment. Yeah, you can go through this, start doing it. If you have any questions, we can discuss in the class. It's due on 10th October. Okay, thank you.